Okay, so if y equals 7, that represents our horizontal asymptote. So we would go up here to 7, and we would have a dashed line here at y equals 7. And then we would use those to guide our graphing. So the point of this warm-up is to kind of help you guys relate what you were doing with excluded values to your asymptotes. Notice the format of all of these expressions. They all have something on the end, and they all just have a very simple statement here at the bottom. And normally, and I just put X on the top, but actually what you would normally see is a number on the top. You wouldn't have an X on the top. I just did this for simplicity's sake. Unique, you're going to change your answer. Okay, fine, change your answer. All right, so let's look at Miriam. So she is student 4. So let's see, what would make the denominator be 0? And that would be if X were to equal 4. So good job, Miriam, good job. This, remember, is also our vertical asymptote. And then our horizontal is going to be whatever is out here on the end. So that is going to be y equals 1. So perfect job, Miriam, perfect job. All right, Trevor, good guess. Oh, I'm really glad you put that in there. That is awesome. So you had it exactly right with your vertical. What would make this denominator equal 0? And that would be -2. We can't have a -2. And then way to go. There is nothing on the end. So if there's nothing on the end, we would assume that this is a +0, which you picked up on. So nice job. So that then becomes your horizontal asymptote. So very, very good. If we look at uniques, did you already change your answer, unique? We're gonna go to you now. So you are notepad number 8 here. So same thing. If we look at what would need to, what this x would need to be to make the denominator 0, we would get 6, which is what you have. And actually, though, unique, that ends up being your vertical asymptote. I know it's strange because it's x equals, but if you picture a graph and you go to where x is 6, say that's right here, you would end up doing a dashed line through the 6. So actually x equals is a vertical asymptote. Kind of weird, I know, I always get confused by that too. And then for your horizontal asymptote, we look at the number at the end, and it's -5. So we would go down here to where y equals -5, and we could draw in a dashed line for a horizontal asymptote there. So very good. Saxon, Elliot, since you guys didn't put anything there, do you have any questions about what I just talked about? And remember, you guys, that it always becomes more, you know the word, more embedded in your brain once you have seen it multiple times. Oh. Okay, so Elliot, you want me to do yours? Good, Saxon, you should. Yes, definitely do that. Make me proud. Make me proud. All right, Elliot, so number 3. Okay, you guys, so who wants to guess? And Elliot, try and see if you want. What is going to be my x equals asymptote? In other words, my vertical asymptote. Who knows? What would x have to equal for Saxons here, down here at notepad number 3? -1. Good job. I got a -1 from unique. Perfect. And what would be my y equals asymptote? In other words, my horizontal one. What would that one be? Very good, Trevor, -3. Awesome job. So you guys, now you understand how to graph, well, how to find the asymptotes for a simple rational expression. And so if we want to answer this question, how do the vertical asymptotes relate to the excluded values? They are one and the same. They are one and the same. Okay? And let's actually, what I want to do is kind of take you guys over to the Desmos and check it out really quick. So if I were to really make an equation correct, I would actually need to change this to be a number. So we'll just call this 4 or something. So I'm going to graph, actually let's actually graph one that you guys did already. Let's graph Miriam's. So let's just call this, we'll call that 2. And the number doesn't really matter. It doesn't change it very much. You'll see. All right, so we're going to graph Miriam's. And notice that our asymptotes are 4 and 1, so we have 2 over x minus 4 plus 1. So if we go and graph it, 2 over x minus 4 plus 1, 2 divided by x minus 4 plus 1. All right, so hopefully you guys can see this. It's going to pop up on your screen. You guys, so notice how this rational expression looks graphed. It's pretty wild, isn't it? It's got these 2 legs, and then you guys can see there's this gap here. So if I go back to what Miriam said, we have an x equals 4 and a y equals 1. I'm just going to graph those asymptotes. So x equals 4 and y equals 1. Look at this, you guys. Look at the graph. I'm pointing, you guys. I'm pointing. This blue line, this is my vertical one, right? Notice that the ends here on these legs are getting really close to the blue line, but they're never going to cross it. Remember, that is your definition of an asymptote, right? That's a value. It's a limit. If you get to calculus, you'll understand that this line is going to get really, really close to but never reach. Same thing with this green line here. That is your horizontal asymptote, y equals 1. Notice that the other end behavior is getting really, really close to that line, but it's never going to touch it. Same thing with the other side too. So those asymptotes are going to help you to guide you to graph these equations. And these equations are really easy to graph because you really only need a couple points for each leg, and then you can see this pattern and you can just roughly sketch it in. So that is why today we are going to look at asymptotes, because no, Unique, no, don't use Desmos to graph. You know what, you could use Desmos just because then you don't do it on your own and then you don't learn it as well. But now that you have actually done it on your own, what you can do then is use Desmos to check your work and see if you were accurate. So it's kind of a good check. But no, you did it fine. Definitely you should do it by hand. I'm just doing a quick one. Okay. All right, you guys. So our objectives then are to find asymptotes in both simple and general rational expressions. And we just did the simple rational expressions. So I wanted to show you the difference between simple and general today, and then answer any questions you guys might have. And here's our important information for success. Remember to work on math each day so that your brain is always thinking about it. And then make a plan for what you want to complete each week. So Saxon, it sounds like you have a plan. That is good. Elliot, you have a plan. We've talked. That is awesome. And you're already actually in the throes of it. So very good. And everybody else, you're on the right track. You're doing great. So let us start. Okay. So just to refresh, here is our simple one. Okay. Elliot, are you with me? Type something in the chat box like, yes, Miss Elliot, I'm with you. I'm going to ask you a question. Oh, good, Elliot, good. Okay, Elliot, tell me, looking at this equation, what is the vertical asymptote going to be, my x equals? What do you think? All right, Elliot, no pauses. No question marks, not right, Elliot. You must give me a number. There's only 3 numbers in that problem. Oh, Unique, I think. Oh, maybe you turned it in late. Like I thought I graded everything, but I graded yesterday, but then after about 2, I didn't grade anymore. So, okay, Elliot, 5. At least I'm really proud of you that you. Oh, it's okay. I don't really count late, Unique. I really don't. But so you'll be fine. I'll grade it today probably. Elliot, so 5. Okay, so remember that to find our vertical asymptote, we're looking at what makes our denominator equal 0. So what would I plug into x to turn that into 0? What do you think? Elliot? Yes, very good. So our vertical asymptote is +1. All right, Saxon, are you with me? Say yes, Miss Elliott. Oh, very good, Saxon, very good. Okay, based on our discussions, what would our horizontal asymptote be? Just on the simple one, what would it be? Give me a number from 1 to 20. No, I'm just kidding. Not really 1 to 20. Some number. 5. Okay, you gave me the same one that Elliot first gave me. Okay, but remember that our vertical one So if this was an equation, it's set equal to y. If our main body of our equation were to go away, what would be left? What number would be left for y to equal? Yes, it would be 6. So our asymptotes are x equals 1 and y equals 6. Coincidentally, x equals 1 is also our excluded value. All right, you guys, I'm going to need your help. So we're going to look at these equations and we're going to find vertical and horizontal asymptotes. These are general rational equations. So this part is kind of new and I just wanted to briefly go over it. It's actually not very hard, but what I want you guys to do is, who's really good at factoring that wants this first one? Actually, lots of you guys are good at factoring. I'm going to give it to Brianna. Okay, Brianna must have left. Okay, so then I'll give this to Miriam. So Miriam, this one is yours. I'm putting your name on it. Can you just do me a favor and factor the denominator? Just factor that denominator. And then, no, you cannot control, Saxon. And then on the second one, all right, unique, I'm going to give you this one. So just factor my denominator. It's mine, I own it. And then Brianna, I think you just went in and out, so I don't know, so I'm gonna give it to Trevor for now. Brianna, are you with me? Oh, now is a good time to randomly restart. Oh no. I'm sorry, Brianna, that is not good. That happens though. Trust me. That definitely happens. Of course it always happens when you don't want it to. Oh, and I just noticed that my picture keeps going away too. All right, you guys, so I assigned you guys some of these to factor. If you are not assigned it, like Brianna, because I know you restarted, or Saxon, or Elliot, because Elliot, we've been factoring, go ahead and try to pick one and factor it anyway, just so that you're not hanging out bored. And let me see if I can get my picture back up, you guys, so give me 2 seconds. I did that last time too. Okay. All right there. During my earlier webinar today, it kept blacking out my face. I don't think it really wanted me to be in the photo for some reason. All right, so, okay, so Unique has already factored hers. So thank you, Unique. Very good. Let me write yours here. Okay, so this one factors as x minus 3, x plus 3. Very good. Unique difference of squares. Elliot, remember that? Difference of squares. All right, and Trevor is working. Ah, see, Elliot, we did like 2 problems with difference of squares. Now you're seeing it again, and you're like, yes, I remember, Miss Elliot. This is good. It's coming back to me. And Brianna, you have got, oh, no, wait, no, Brianna, sorry, I didn't assign you one. Your computer was on the blink. Miriam is working on this one, and Trevor is working on this one. All right, Trevor, remember, just set it equal to, or actually, no, you don't have to do that. We're not solving. Just what can you factor out of 2x and out of 20? What comes out of 2? Very good, Trevor. Yes, you were exactly right. Keep it up. That perfect, perfect. All right, so Trevor has factored his. It is 2x minus 10. Excellent job. And Miriam is working hard. I know, Miriam, I gave you a long one. This is true. Oh, Elliot is working on it too. Elliot, I like it. Now, the only thing is, Elliot, if you look at the 6 and the 1, those do multiply to give you 6, but remember they both have to add to give you 5. You know that little trick with the x? So Elliot, you're on the right track. I like your enthusiasm. That was good. Oh, you can subtract, but then you would need to have 1 be a minus. So you'd have to either have the x minus 6 or x minus 1. You'd have to do that. But remember that when you multiply them, still has to equal 6. So like Elliot, if you do, just because Miriam's still working on it, so if we made our little x, Elliot, and up here we have 6, and down here we have 5, what times what is positive 6 that adds to be positive 5? Okay, so you said 6 and -1, right? So if I were to put, I'm going to put it out here actually. 6, that was a really good try, Elliot, really good try. 6 minus 1 does equal 5, but does 6 times -1 equal +6? Sometimes these can be a little bit tricky. So if we kind of look, no, Elliot, no. Did you just not say yes? Oh. No, Saxon, no. So if you erase these and we put in 3 and 2, so Elliot, look at those, look at that combination. 3 plus 2 is 5 and 3 times 2 is 6. So it can definitely be a little bit tricky. Miriam, you have the right factors on that one, by the way, just to tell you. So yeah, Elliot, sometimes it's kind of tricky because 6 and 1 do make 5, but the problem is there's no way to do the negatives to get it to be +6 that way. So that was a really good try, Elliot. That was a really good try. I want to encourage you to keep doing that. That was awesome. So x plus 2, x plus 3 ends up being our factors. You did it too fast. Hey, but at least you're doing it. That is a very good thing that you're trying it. All right, you guys. So what I'm going to do is I'm going to write down the x equals first, the vertical ones, because that does not change. So you guys know how to find the vertical ones. It's whatever makes the denominator be 0. Well, in this first one, if we had a -2, this would be 0, which would make our whole denominator 0. And in our second factor here, a -3 would make that be 0. So for this general rational function, we actually have 2 vertical asymptotes, one at x equals -2 and one at x equals -3. So there's 2. Same thing with this one that Unique did. We have one at x equals 3, and we have another one at x equals -3. So you guys will see when you watch this lesson how strange these legs can start to look. And then Trevor, the one you have only has 1. And that's because 2 doesn't have an x by it, so all we have to do is look at what x minus 10 would make that be 0, and that would be +10. So nothing new for you guys here, right? Oh, Saxon, you're trying to activate your mic? Oh, you should be able to activate your mic. I don't know. I think it was telling me you were trying to take control the scene. So anyway, so you guys, vertical is the same. Okay, so here's your difference. Notice these 3 general equations. In the first one, if you look at the highest degree of your exponent, this top one is 1 and the bottom one is 2. So this is called bottom heavy. Everything is in the right proportion, right? It's like 2/3 versus 3/2, right? 2/3 is normal. 3/2 is not, right? We have a improper fraction. So if we have it like this, then our horizontal asymptote is always just y equals 0. Really easy. So if our degree for our numerator is less than the degree for our denominator, in other words, we're bottom heavy, we know our horizontal asymptote is always just y equals 0. Don't have to calculate, very simple. Let's look at this middle problem that was unique here. In this case, notice our degrees. We have a 3 on the top, and then we have a 2 on the bottom. Now we're top heavy. That's bad. So anytime we're top heavy, then we don't even have a horizontal asymptote. It's NA. You don't even have to calculate anything. We just don't have one. What we actually have, but you won't learn this until pre-calc, is we have an oblique or vertical asymptote, and we can find it by dividing. But we're not going to do that. That's kind of beyond our scope. So all you have to know is that we don't have a horizontal asymptote. Okay, last one. In this case with Trevor's, notice that the degrees are the same. This is x to the first power, and this is x to the first power. Anytime the degrees are the same, all you have to do is look at the coefficients of that x term. So we have 10 and we have 2. What you do is you take 10 over 2, just like it's written, and you simplify that. 10 divided by 2 is 5. So our horizontal asymptote would just be y equals 5. All right, you guys. So, quick recap. Vertical is the same. We always look at what would make our denominator equal 0, right? We're always looking at the excluded value. It doesn't change. Horizontal, though, if we're bottom heavy, it's always 0. If we're top heavy, we don't have a horizontal asymptote. And if they're the same, we divide our coefficients. Okay, what questions do you guys have on these asymptotes? Any questions? All right, Saxon. That is fine. Work hard. Work hard while you're there. And then unique. Oh, you never factored the denominators? Brianna, you're good. Well, so unique, did they need to be factored, or was it just like, or were they already factored? I can't remember how I listed it. So you never factored. So how did you find the vertical asymptotes? Unique, was it, and maybe I could go back and look. I can't remember the problems. But were they, maybe they were, or maybe I gave them to you already factored or something. Did I do that? Trevor, Miriam, are you guys in good shape? Good, Trevor, good. Oh, never mind. You did. Oh, you looked at your work. Good. Very good, very good. All right, I was going to say, you usually always factor, so it's hard for me to imagine that you would not factor. All right, so if you guys feel like you're good, you're going to look at this. So what we're going to say is, I'm going to give you guys, this is your final task of the day. So Trevor, this is for you. I changed it. Unique, let me see. Oh, I only have 6. Left one off. Well, Saxon's gone. So unique, I'm actually going to put 8 here because you're an 8. So that's going to be you. Oh, see, now I give you an easy one, unique. Oh, I shouldn't have done that. Actually, you know what? I'm going to give that, you know what? I'm going to switch them around. So never mind. So hang on, unique. This is not you. Elliot, you're number 3. And unique, here's your number 8. Okay, so now has everyone got one? Brianna, you're 2. So we've got 8, which is unique. Number 4 is Miriam. Number 6 is Trevor. Okay, good. All right, you guys. Determine the vertical and horizontal asymptotes for your problem. This is our final task for the week. Well, for the webinar, I should say. Okay, good. All right, Elliot. You got this. Are you there, Elliot? Awesome. So think about the one that we just did. Very good, Elliot. You're thinking. Miriam is off and running. And Trevor, are you there? You are what number are you, Trevor? 6. Okay, good. Okay, good. All right, you guys. So I'll give you like a minute or something, and I'll pause the recording. I feel sorry for all the people that are trying to watch this video because I pause it and forget to unpause it. But anyway, so, oh, Trevor, you did it. You've got it, and you're in good shape. You have your vertical. Oh, did you do your vertical? Oh, I'm sorry, Trevor. I'm sorry. One more. Let's look back at your vertical. So Miriam got this part. It's funny, if I could put you and Miriam together, you guys would have the perfect answer. Okay, so you have 2x minus 6. So remember that if you want to solve for x, actually I'll do it the way you did it. You factored it, so let's actually do it that way. So you factored out a 2, which is perfectly fine because that's what we've been doing, is a ton of factoring. So then if you look at that, what would x have to be to make this turn into 0? So what do you think that is, Trevor? What would x have to be for your vertical asymptote? X would be 3, you got it. You got it. Good job. So now you're done, Trevor. Sorry, I was just moving on without you. But anyway, good. So the one up here in notepad number 3, that is your simple rational expression. And then you guys got some practice doing the more complex ones. Just to recap, remember to find the x equals, which is our vertical asymptote, it's the same whether it's simple or general. And then to find our horizontal asymptote, if it's simple, it's always the number on the end. If it's general, remember bottom heavy, it's 0. Top heavy, it's NA. And if it's the same heavy, then we divide our coefficients. All right, you guys, any questions now? Very nice job figuring those out. Way to persist, way to keep working. Okay, nope and nope and no. I should be like, do you guys understand it? And then you can be the positive answer. So yes, yes, yes. All right, and unique, I know. It helps if you write it down. Yes, yes, this is true. True, true. Okay. All right, you guys, so for your ticket out this time, it's a good ticket out. All I want you guys to do is write one thing that you learned and one thing that you have a question about. Even if it's a question about some other lesson that you did, that's fine too. And then respond to 2 other people's questions, or you can reflect on something that they wrote that they learned that maybe you didn't know and reflect on that. So that's what you guys have to do for the discussion. Not too bad. That'll give you a chance to kind of read different people's perspectives on what they learned versus what you learned and stuff like that. So I think that's it. You guys need anything else, or how do I spell that word? Like asymptote? Elliot, or oh, you want, okay, so here. And if you spell it wrong, it's okay. I won't mark you off. But if you spell it A-S-Y, asim, like that, M-P, T-O-T-E. So like tote on the end, asim, I don't know. It's kind of a strange word, actually. But hopefully that helps. Okay, any other questions that you guys might have?